director of the Science and Conservation Center, Billings, Montana. And I'm going to talk about wildlife contraception, and I have a couple goals and objectives that I want hopefully will achieve with this particular talk. Oh yeah. After further review, the play will stand as called on the field. I always wanted to do that with one of these things. Anyway, the title of this talk, of course, is The State of the Art of Wildlife Contraception. That may seem bizarre to some of you, but it's not as bizarre as it might seem. There are several goals and objectives within this talk, and you see them up on the screen. But there's another really overriding objective that I have. This whole subject is very emotional. It's strident, the discussion around it. It's been an issue here in Pittsburgh. And I know that quite a few experts have found their way through Pittsburgh, both from agencies and other academic institutions. And primarily their message has been, this doesn't work. It's interesting that all these witnesses, expert witnesses who have paraded themselves through Pittsburgh have never themselves been involved in any wildlife contraceptive projects of any scale. And they have offered to you a variety of opinions and ideas and conjecture and assumptions. But they haven't given you any numbers. They haven't given you any data. What I'm going to talk about tonight is not opinion, not conjecture, not assumption. I'm going to talk about numbers, tables, graphs, all of which have been through the peer review of science and published, but not opinions. And so my real message underlying this talk, the real goal and objective, is to make it really clear that it works, despite what you may have heard. Urban deer. This was the next thing we tackled. The first project with deer was with captive deer. Dr. Cohn here funded that way back in 1990. And I'm going to try one last time. This is about the 10th or 11th talk I've given in the last 10 days. And I've asked this question to every single audience. And I haven't had a single hand go up that knows the answer yet. We did this study with a captive herd in Wapakoneta, Ohio. Who knows what Wapakoneta, Ohio is famous for? See, they tell me today that, particularly for most students, history begins in somewhere around 1985. That's the home of Neil Armstrong. All right, we're still batting 100 on that one. We treated 7 deer. We got absolutely no funds, so we showed that it worked in captive deer. From there, we went to the Smithsonian Institute's Conservation and Research Center in Front Royal, Virginia, 3,600-acre facility with a lot of endangered species on it. And we caught a whole bunch of deer. We put ear tags in them, and we gave them the first shot by hand. And we gave them any booster shots that they were to get remotely with the dart gun. And we hid under haystacks and sat in trees, and we even had the interns from the National Zoo drive us around in pickup trucks. We sat in the back, and they would spotlight the deer at night, and we'd dart them out of the bed of the pickup trucks. And the only thing that seemed like was missing was some guy named Bubba and a crock jug. But we managed to get all these deer, and we learned 4 important things from this study, very important. By this time, the opponents of contraception were becoming quite alarmed. They didn't care too much about wild horses, but when we moved on to deer, that really stirred the pot. And the opponents came back with all kinds of arguments. What's the first thing we learned? The first thing we learned is that in deer, as opposed to horses, they will extend their breeding season by up to 2 months if you treat them. And of course, the opponent said this will cause a huge energetic problem. In the winter, 2 additional estrus cycles. This will be really hard on these deer from an energetic standpoint. So we caught them the following summer, and we weighed them. And here's a bit of real rocket science for you. The treated deer who extended their breeding season by 2 months and didn't get pregnant were on the average 20 kilograms heavier than the untreated deer who didn't extend their breeding season but got pregnant. And by fall, all the differences were gone. So there was no energetic cost. The second criticism was, oh, with that extended breeding season, the bucks now are going to wear themselves out. And they conjured up visions of meadows filled with dead deer in the spring with smiles on their face. And as it turns out, this was very interesting. I mean, all of these questions were probably okay if they hadn't been so biased to begin with. But we learned some things. For example, we learned that all the early breeding up through December was done by the big bucks. And then they quit. And they had no interest at all in those does with the 2 additional seasons, estrus cycles. They went off and laid down a corner of the paddock and ate grass and stayed out of the things. The young bucks, spikes and forkhorns, followed, not with a frenzy, because remember, their testosterone levels are going down. And they're not allowed near estrus does when the big bucks are active. But the big bucks quit. And now these young bucks sort of followed the others around. But there was no frenzy, hardly ever even breeding. So that wasn't an issue. The third thing we learned was that when the study was over, 2 or 3 years down the road, we unilaterally ovarectomized these does, sent the ovaries to Linda Munson at UC Davis, and there's no effect on the ovary at all. And that was important because in some species like rabbits and mice, there is an effect on the ovary. There was no effect on the ovary. And the fourth thing we learned was really interesting. If we get some of these deer, we just gave them a single shot in the fall, just a single shot. And the following spring, guess what? They all had fawns. We didn't contracept much at all. But when we gave them that single booster the second year, contraceptive levels went right up to the ones that had received 2 shots the first year. And everyone had been saying, this whole thing is useless unless you have a 1-shot vaccine. And we're spending a lot of time, energy, and money on that right now. But we didn't need to, because if you're willing to throw the results out for the first year, then you're there. Every deer is a 1-shot deer. So those are the 4 things that we learned. And one by one, the scientific arguments against this were falling. Our first chance with